report screen, correct? Someone just wants to kind of mic in and let me know that you can see the screen.
Yeah.
Perfect. I'm going to try just doing all of this from my laptop today. I don't need the use of the calculator, so I'm just going to try doing everything from the laptop, see how that goes. But I won't be able to check right away. I won't be able to check to see messages. Okay, so if you have a message, be patient. Or if you need a question, just unmic and let me know. Okay, or if anybody sees a question off to the side, let me know, because I don't see that with my laptop. But what I'm going to do is I'm going to quickly go through a quick review from yesterday. I'll take up your homework from yesterday, and I'm going to get you guys working today, okay? Let's just review what we did yesterday. Yesterday we went through, and if you can picture at the start, what we've been doing in all of chapter 2 is a bunch of scatter plots, right? You know, a variable at the bottom, a variable at the side, golf ball height, and then the rebound height, or weight on a spring, distance from the ground, tibia length, leg length. We've been doing all kinds of these scatter plots. But we got to a specific scatter plot we call the distance time graph. And the reason is we've got time on the bottom, distance on the side. And you're going to see a lot of these graphs in high school. And you guys watched a little video yesterday to get introduced to what these distance time graphs are. We went through this here, and just to refresh, when we're going up to the right, that means we're walking away from that CBR. We're walking away from wherever that stationary thing is. And because it's not too steep, we're going slow. As soon as you still go up to the right, but much steeper, walking slowly becomes running. Like you're going really quick right here. They're both going up to the right though, so you're going away from the CBR. A flat line indicates you're not moving, but then lines down to the right indicate that you're walking back towards the CBR. So look at how far you are from the start here, from the CBR when you start at time is equal to 0. And when you end your trip, look at how close you are to the CBR. So if this is the CBR in class and you're over here, look at that great picture. I should have been an art teacher. You're walking towards the CBR and you end up really, really close by the end, okay? This one here, you walk very slow towards, but then you stop at the end, that flat line. There's 2 phases to this one. This one, you walk away slowly, stop, walk back towards very quickly. And then you had a couple here. You go like a jog to a walk to a run. You're all moving away. Kind of a jog here or a walk. This is a slower walk. And then this is more of a run. But this one here, you run, stop, and then probably walk. And you have them here, okay? Everybody good with that? I'll check the messages here quick, but everybody good? Any questions on that page? We did that yesterday. Let's go to the homework. Very first thing, or very first page was write about the starting position, write about the ending position, and then the direction of change and any speed. So we're going to get a little more into this with actual speeds and things of that nature, rates of change back in chapter, or going forward in chapter 5. But for right now, here's what I was hoping you would say. If you treated these as meters and these as seconds, you could say I started. And what did we do? Every other line was a meter yesterday. Can somebody help me out? Was this 0? And then we skipped a line 1, skipped a line 2, I'm pretty sure.
Yeah.
Okay. So if you wanted to be precise, you started 1.5 meters away. After 1, 2, 3 seconds, you were then 3 meters away. So you were walking away slowly. You stopped for 3 seconds, 1, 2, 3. And then you went quickly back to the CBR and you ended up right at the CBR. I think the trip took 1, 2, 3, 4, 5, 6, 7, 8, 9 seconds to complete. All right. Yep.
Sorry. This is kind of a stupid question, but the bottom line, is that like the whole line means the CBR?
As soon as you ever get back to this line, your distance up on this axis is nothing. You're at the CBR.
Oh, okay.
So as soon as you get back to here, your distance from the CBR is 0. As soon as you get to here, your distance from the CBR is 1. This is a 2. This is 3. Distance away from the CBR because of this scale. Does that make sense?
Specifically that corner.
No, this is not the CBR. You don't go back here to get to the CBR. The CBR is when you go down to here. This is time And unless you're Back to the Future, you can't go back in time. You can't be moving backwards on time, okay?
Okay, so the whole bottom line is the CBR, the whole thing.
You can consider it that, yep. It's just the CBR distance is 0. That's what this line means. This line here means 0.5. This line means 1. So anytime you get to this line on your graph, right here, you're 1 meter from the CBR.
And then for the is that the Y goes, Y is the vertical line, right?
This is Y
ver-
right here. This is your
Yeah,
distance
Y-
from the CBR. This is your time, the X.
So if you go up, that means you're walking away, and if you go down, that means you're walking towards it.
Absolutely.
Oh, okay.
Okay.
Yeah.
So for this one here, you would start 1, 2, 3, 4, I think 4.5 meters away, if I counted correctly. So you're starting 4.5 meters away from the CBR. You walk slowly towards the CBR, you stop for a little bit, 3 seconds, and then you go quickly towards the CBR and you end up right at the CBR. Distance from the CBR is 0. Okay? This one, you start right at the CBR. You walk away from the CBR quickly. You walk back towards it a little less quickly. This is not as steep as this one. So a little less quickly, but at a 0.5 meter, you stop the rest of the way. So far, so good? And the last one, start right at the CBR. Walk away quickly, change speeds, and just go a little bit slower, but at a constant speed. Walk slower, away. Stop. But now if you take a look, at this graph, do you see the curved line right here? You are increasing your speed. You're increasing while you walk towards it. It's a curved line, which means this is flatter than this. You are increasing your speed as you go towards the CBR until you get to, it looks like 1 meter, 2 meters away, and then you decide to walk at a constant speed again. This is a constant speed, not moving, increasing your speed continuously, like you're accelerating, and then it's a constant speed again because it's a straight line. All right, is everybody good with this one? Any questions? We're going to get a little more practice with this today, okay? Now, you had to sketch each of these. I'm going to take this one up with you, and I'm going to leave the second one with you to try, just in case you were not able to do it. So yesterday I told you, make sure that this is going to be 1 meter, 2 meters, 3, 4, 5. So I'll put these where they should go. 5 is right there, 4 is right there, 3, 2, and 1. So that's how far away, okay? And we could even just put 0, knowing that 0 is right down here, okay? Now, I'm not going to label every line here. Whoop, get back here. I'm not going to label every line on this one, but I do know that this is going to be 0 right on the axes. I'm going to skip 1, 2, 3, 4, but I'm going to label 5 right here. 1, 2, 3, 4, this is 5 right there. I'll duplicate this. 6, 7, 8, 9. This one here is 10. And then I will duplicate this again, bring it to 11, 12, 13, 14, and 15, I think is right here, okay? So we now have our scales, and let's see if we can mimic each of these. The very first thing that says to do is begin 5 meters from the sensor. That's going to be a dot, and we're going to start 5 meters away. Right here. Walk towards the sensor. So I know I'm going to be going down to the right. Walk towards the sensor for 6 seconds. Okay. So I'm walking for 6 seconds. I'm just going to help myself out. 1, 2, 3, 4, 5, 6. When I end, I should be at this line. So the line I'm creating from here should end somewhere in here. I just don't know where it ends yet, okay? It says at a steady rate of 1 meter every 2 seconds. Okay, so if I'm going to walk for 6 seconds and it takes me 2 seconds to walk a meter, in 4 seconds, double it, I'm going to go 2 meters and put another 2 seconds on for 6 seconds. I'm going to go 3 meters. Does that make sense, everybody? If I'm going to walk for 6 seconds and every 2 seconds I'm walking a meter, I'm going to walk 3 meters. So I'm going to get, and if you're watching here, Connor, I'm going to get, this would be 1 meter closer. This would be 2 meters closer. I want to get to 2 meters away, which means I moved 1, 2, 3 meters closer in these 6 seconds. Does that make sense to everybody?
Sir, for the thing, is it like, I don't know how to explain it. Is it like possible for it to be exactly the same every time? So say if we all had the same question, it's exactly the same, or is that just like, if it's close, it counts?
If everybody had the same scale that I have right here, your graph should be exact. Now, if you didn't have the same scale, if you made a different scale here or a different scale, it would look the same, but it would either be compressed or stretched. The general shape would be the same, but it would just be compressed or stretched. But since we all have the same scale, and I think I did this one with you yesterday, you should have this exact graph. Okay?
Okay, it's just because mine was like a bit like steeper, so I wasn't sure like if
Then
it had to
you
be.
didn't end 2 meters away. You have to end 2 meters away after this first
I
segment.
went 5 seconds, not 4.
You went
I
what?
mean, I went 5 seconds, not 6.
Well, it says 6, right?
Yeah,
So that's why.
I just lined up wrong.
Yep, okay, as long as you know. Now, from this point, we're going to stop for 5 seconds. So if we're at 6, 5 seconds would be 1, 2, 3, 4, 5. That would be 11 seconds. So when we stop, we're going to go from here, and we're going to create a flat line going across until we get to 11 seconds, which is right here. So I'm going to keep this line going until I get to 11 seconds. Does that make sense to you guys? Stop for 5 seconds. From 6 seconds till 11 seconds, there's your 5 seconds of stopping. This part's done. Run back to your starting position. Well, here's where I started, 5 meters away. So run back to your starting position. Don't do this. Don't go from here and think this is my starting position. You can't go back in time. You're going to still be moving forward, and to get back to your starting position, you're going to be up at 5. I just don't know how long it took me to get there. Until I read the next part, and it says at a steady rate of 1 meter per second. I've got to go 3 meters to get back to my starting position. I'm 2 meters away, and I've got to get back to 5. I'm traveling 3 meters, and it should take me then 3 seconds. So I'm going to move this over 1, 2, 3 seconds. So I should get to 5 meters away at the 13-second mark right there. Does that make sense to you guys? Is everybody okay with that? And the last part says stop. And to show just stopping, it's a flat line until the end of the graph right there. And that's what you should have for your particular graph. Okay. Can you guys put your hands in the air if you understood that graph right there? I'm going to check. Just put your hands in the air. Keep them in the air. Awesome. Okay. Ashton, you good? All right. Yep, we're good to go. Senna, you're good too? Perfect. Okay. So that's the first one. You guys can do this one. Try this one. I'll take it up tomorrow. Okay. I'm not going to do it right now, but those of you that had trouble with it, you now have one to practice. Okay. Here's what we're going to do now. Okay. Here's what we're going to do today. And you guys are going to do a little work for me today. Everything we've done so far with these distance time graphs involved the CBR, that little kind of fish finder device. Every question that we've done is all about the CBR. CBR, CBR, CBR. But here's where we're going to go. Not every distance time graph has to be about a CBR. So let's just take a look at these questions here. I'm going to do this question with you, and then I'm going to turn you loose on some questions here. But let's look at question 1 the next page in your package of material there, okay? We don't always have to have distance time graphs, okay, or these types of distance time graphs with the CBR. So for example, Ian and his friends were sitting eating sunflower seeds. Each person had a bowl with the same amount of seeds. The graphs below show the amount of sunflower seeds remaining in the person's bowl over a period of time. Time, the amount of seeds. Explain how each person eats their seeds. So Ian has his friends over. He goes inside, opens up a brand new bag of sunflower seeds, and pours the same amount in 4 bowls and brings them out and gives them to himself, Mary, John, and Christine. This is how Ian ate his seeds. This is how Mary ate her seeds. This is how John ate his seeds. And this is how Christine ate her seeds. What I would like for you to do is give me a little paragraph, a little blurb about how each person ate their sunflower seeds, keeping in mind the shapes of their graphs and what we learned about distance time graphs so far, especially pages like this, and so on, okay? So take 5 minutes, I'll put a timer up, 5 minutes, and write me a little paragraph, a little blurb about how each person ate their sunflower seeds. I'm going to do a quick attendance while you're doing that. I'll come back, I'll take it up with you, okay? When you're done, put your hand in the air, okay? I'll know you're done. So when you're done, put your hand in the air. How are we doing there? You guys good to go? Take a look. Couple people finishing up. Ashton, Braden, Kuwar, Paula, you guys okay? Perfect. Okay, let's take a look. Somebody want to unmic? Tell me how Ian was eating his sunflower seeds.
He didn't eat any at all.
Yeah, he didn't eat any at all, right? You see that line going straight across, and just like that flat line means somebody wasn't moving with the CBR, it means Ian wasn't eating his sunflower seeds. The same amount of seeds were in his bowl at the end as at the beginning, okay? Let's go to Mary. How was Mary eating her seeds? Somebody new.
She ate all of her seeds quickly.
Okay, let's expand on that a little more. That's a great start, but let's expand on it a little bit more. I was told she ate all her seeds quickly.
She ate them quick at the start, but then slowed down as time went on.
I like that part. Do you see the steep line at the start here? Mary got her bowl of seeds and she mustn't have ate supper because she devoured them at the start. And then she slowed down to the very end when she was just kind of picking through, putting one in her mouth, trying to find another one. So she kind of really slowed down there at the end. Really, really quick at the start and then slow down at the end. If it was the opposite, she wouldn't be eating too quick and then all of a sudden she realized how hungry she was and boom, she ate them all that way. Okay, that would be the opposite. How did John eat his sunflower seeds?
John first he ate like a bit fast, but like not faster than Mary. He was eating fast. Then he just stopped for like about 3 or 4 seconds. Then he went again, but then he was eating slow, but not that fast.
Yep, I like that. Now, we don't know time, so I heard 3 or 4 seconds. It's hard to say how long that time is without a scale. We just know that he ate quickly, stopped, and then he ate again, but it was slower than what he was eating at the start. You don't have to give like 3 seconds or an hour. You don't know the time there. So it's basically just to tell us how he was eating. What about Christine? How did Christine eat?
Sorry.
Yep, go ahead.
On a test, would you want the seconds and stuff?
Well, no, because you don't have any there. You don't know what they are, okay, Connor?
Yeah, but
It's
if
just-
there was,
then you could say yes. You know, they stop for 2 minutes and so on. The whole scale thing is going to come into play more in chapter 5. Here it's just the basic ideas in chapter 2, okay, Connor?
Yeah.
Okay, perfect. What about Christine? Somebody was going to talk about Christine?
Oh, she didn't eat any for like a little bit and then ate a little bit pretty quickly and then completely stopped.
Yeah, so she probably ate about half her bowl and then she stopped, right? How many people finished their bowls of sunflower seeds?
2.
Yeah, I would say 2 also. It looks like Mary finished. She got right down to the bottom, and it looks like John finished. Christine halfway, and Ian didn't really eat his. It wasn't until a few years ago I noticed something pretty interesting about this. Did anybody pick up on something here from the question to the 4 graphs? Did anybody pick up on something? Ian and his friends were sitting eating sunflower seeds. Each person had a bowl with the same amount of seeds. The graphs below.
Yeah, like Ian didn't have like the same amount like Mary, John, and Christine had. He has like half bowl.
You see right here how if we went across, it looks like John has the same amount to start. It looks like Mary had the same amount to start, but look at John. Or sorry, look at Ian at the start. Ian's the host, so Ian probably poured 4 bowls, and either he ran out in the last bowl, so he just gave himself the least amount. Maybe he tripped over his dog on the way out to the back porch, and he dropped a bunch of seeds. The dog ate them all, so he kept, that one there. Who knows? But Ian gave himself less seeds, even though it says they all have the same amount of seeds. Okay? Is that good? All right, here's what you guys are going to do for me. You kind of got the idea, so follow along, and I'm going to give you some time to work here. Don't start these yet, okay? I want you to make sure you know what you have to do. The first question now on your own is this. Question 2 deals about Michelle being late for school. You read the story, and you pick which one of these 2 graphs represents this story. Once you pick the graph that represents the story, whichever one you didn't pick, let's say you picked this one, write a story about how she would have went to school if it was the other graph. Okay, question 2, good? Match the graph to the story. Whichever one you don't use, write a story about her going to school.
Wait, sorry, sir, I'm a little confused on that one.
Why are you confused, Ashton? Michelle's late for school. She runs halfway to school. Then she gets tired and stops for a short rest. Then she walks the rest of the way. One of these two graphs is that story.
Oh, okay.
Whichever one you don't use, the unused graph, write the story like up here, over here for that graph. Does that make sense?
Yes.
Okay, perfect. So by the end, you're going to pick the graph and you're going to write the story for the unused graph, okay? Next, describe the motion here. You can use a CBR. How did this person move? Okay, question 3. Question 4. Mark walks to his friend's house. Partway there, he realizes he forgot a CD. He runs back to pick up the CD. Then he walks back to his friend's house. So this right here is going to be time, and this is going to be distance from his house. Those are the two variables. You can draw the graph, okay? Everybody good for that one? And the very last one, okay, really pay attention here. You ready? Below the following graphs are 3 stories. We have 1, 2, 3, 4 graphs, but we have 1, 2, 3 stories. There's 4 graphs, 3 stories. So 2 of these stories match 2 of the graphs. Your task is to read each of these stories and see which one matches the graph. Only 2 of them correspond, 2 greens to 2 yellows. That means there's 2 yellows left over. Whichever 2 yellows are left over, I want you to write a story for the 2 unused yellows right here. Whichever 2 unused yellows, write a story for them. And then the unused green story, I want you to create a graph for. All right, does that make sense? 2 of these graphs match 2 of these stories. That means there's 2 graphs left over. Write the 2 stories for those graphs. And if 2 of these match 2 of these, that means there's 1 story left over. You write the graph for it. I want everybody to put their hands down, and when you are done this page, put your hand in the air.